Welcome back, students. In this video, I will discuss about insulators and resistors. I was to discuss about some board questions, but I thought I will cover a few more topics and then club all the board questions together. So in this video, we will discuss a quick recap of conductors. I would suggest you to check part 1 video to have better understanding of conductors and how they conduct electricity. Why this recap is required is basically I'm trying to explain about insulators, resistors, and finally compare these three: conductors, insulators, and resistors. So a brief understanding of conductors is very much essential for you to do this comparison against insulators and resistors. So as a recap, we saw the structure of the atom in part 1 video, where there are electrons outside and protons and neutrons are the nucleus. Electrons are negatively charged, and these electrons and uh, protons attract each other because like charges repel and unlike charges attract. So in the case of a conductor, there is only one electron in the outermost orbit which is free to move because it is far away from the nucleus and it is not strongly bound by the attractive forces of the protons. When you provide a push, that push, it's provided by the battery or a voltage source. This electron becomes free to move. When this electron moves, the current conduction starts. That's how conductors conduct electricity. So request you to check part 1 video again for all details. Now we will move to see how insulators are arranged. In the case of insulators, most important point is they have more than 4 electrons in the outermost orbit. So insulator is any material or any substance which has more than 4 electrons in the outermost orbit. In this case, you can see 1, 2, 3, 4, 5, 6. There are 6 electrons. And they are tightly bound, means they are held tightly by the force of the attraction force of the protons. Thus, insulators do not have any loose electron to conduct electricity. There is no free electron which can come out like this electron and move around to generate electricity. All are closely bound to the attractive forces of the proton and they cannot move and hence they do not conduct electricity. So this is called as insulators. When it comes to resistors, these are specially designed materials. Like you bring in two what to say metals, or you create an alloy basically, so that you can have a resistance of a particular value. So what is this resistance? See, resistance are devices specifically designed to resist or limit, note the word, to resist or limit the flow of electric current in a circuit. Say for example, this is just a very crude example. You need to reduce the current. Say in the circuit there is 8 amperes. Only to a particular component you want to reduce it to say 10 amperes in the circuit and 8 to the component. So you add a resistor so that it reduces 2 amperes of current. It limits. So nichrome is one example. So this resistance can be fixed or variable. We will see more about this resistance in the next video. For the moment, you just only understand that it is can be fixed or variable. Variable means you can have different values of resistance. Fixed means it's one single value. Unit of resistance. How do you measure the units of this resistor? So these resistors are measured using a value or a property of a material called as resistance, and that resistance has a SI unit of ohms. So where do you find the uses? Like it is basically used to protect components and control the current. See, for example, you would have seen a couple of LED lights where you can reduce the brightness, or our fans where you can reduce the speed. So how does that happen? So it is by this resistance. When you rotate the fan regulator, or when you operate the switch or the power of the LED lights, it reduces the current that passes through it. How does it reduce? It is because of these resistors. So it is used to control the current passing through the circuit. So this resistor and resistance is a big topic by itself, which we will cover in our next video in detail. And for the moment, we will see what is the difference between conductor, insulator, and resistor. See, conductor we have we saw that it conducts current easily. Insulator completely blocks current flow, whereas a resistor is a way between uh, conductor and insulator. It's between conductor and insulator, so it has a restricted current flow. So resistance is a property of a material, which we will see in the next video. But for a conductor, the resistance is very low. There is no resistance to current. Current is free to flow. That's why it is a conductor. Whereas for insulator, there's a very high resistance. That's why there is no current flowing through a insulator. Whereas a resistor will have a specific value. You can define what amount of resistance is to be given. So that is a resistor material. Free electrons. We saw that a conductor usually has one free electron in the outermost orbit, and there are many such conductor material. I'm not telling conductor. The metal, whatever is used, has one free electron, and a conductor has millions and billions of such atoms or electrons. So they have plenty of free electrons. Whereas an insulator has no or has very less few electrons, which is not sufficient to conduct electricity. Whereas in the case of resistor, it's always in way between conductor and insulator. It has a moderate number of free electrons. Okay. Example, see whatever you see in the conductor is a pure metals like copper, iron, silver, aluminum. These are all good conductors of electricity. Whereas insulators, they don't conduct electricity. Example, wood, glass, plastic, rubber, they all do not conduct electricity. So these are all examples of insulators. Whereas for resistors, it is artificially designed. I mean, it is designed and man-made. So it's a mix of two metals. So example, nichrome. Alloy is made from carbon and nichrome. Then the purpose for conductor, obvious, it is to carry current. For insulator, it is to prevent current. And for resistor, it is to control current. It is controlling, it is increasing or reducing the flow of current. See, you can see a practical use. So conductor, the copper wire, whatever you see, that is a conductor which is carrying current, and the insulation material outside the copper wire, because if the copper wire is bare, you cannot really use it for your day-to-day applications. You will have an electric shock. You need an insulator around the conductor to safely handle these electric devices. That insulator is usually a kind of plastic or rubber material that prevents the current flow and thus protects you from the underlying conductor from electric shock. A resistor is a control current. That is what we saw. A fan regulator can be an example. So if I should tell in a very, what to say, day-to-day example or a common life example, conductors are something which can be seen as a wide open road. Many people can go in and come back. Many people can move. There is a wide road. Whereas an insulator is like a wall. It's like you really, nobody can go the other side. So resistor, you can see like a gate which has a narrow pathway, a road with a narrow pathway, lot of hurdles and a gate. So people cannot freely move around. So that's how we can see a resistor. So we close this topic, and the next video we will cover a more important topic on resistor and resistance. Bye and thank you till then.